All right, so we're going to take a look at factoring a trinomial with an a value that is something other than 1. So what am I talking about a value? So a quadratic in expanded form can be written as a times x squared plus bx plus c is equal to 0 or y most of the time. So the quadratic term is the term with the x squared. It's called quadratic term because if I graph it, it will be a parabola. And so the a value is the coefficient of the quadratic term. The coefficient simply means it is the number that we're multiplying times the variable that is squared. We have our linear term. This is called a linear term because if I graph b times x, I will get a straight line. I'll get a straight line. And so b is the coefficient of the linear term. And then c is called the constant. It's called the constant because it will not change. It is constant. All right, so in this problem, we have a coefficient for a that is not 1, and we also have a coefficient for c that is not 1. Therefore, we are going to have to factor this, and our normal strategies may not be as efficient. So what we're going to do is we're going to make a possible factor table and a possible sum, and we are going to do some guessing and checking, and then at the end of this, I will show you my shortcut on how I do these problems. So, well, it's not really a shortcut, but it's how I mentally did it when I was a student, and I still do it that way, so I'll just talk you through that. All right, so the question is, I know I have to have a binomial pair, so that's 2 sets of parentheses. Will I have a positive, a negative and a negative, or will I have one of each, one positive, one negative sign inside my binomials? Which is it? Yes.
Positive or negative?
It's going to be a positive and a negative. What was the clue that I needed a positive and a negative? Okay. There's one addition sign, one negative sign, and in particular, the constant is negative. That means I have to multiply 2 numbers together to get a negative. The only way that happens is if I have a negative times a negative. Good morning!
I get to be upstairs.
Welcome! You finally graduated, Billy Madison. All right. I'm glad that you could be here for this big moment. I'm glad you could be here too. All right. Yes. All right. So the question is, what times what is 18z squared? What 2 numbers multiply together to make 18z squared? All right. Hunter?
9 and 2.
9 and 2. So we have a 9z and a 2z. Now, I put a cross through the z's so I can tell them apart from my 2's, which is really helpful. Now, I can't help but notice that 18 is a tricky number here because 1 and 18 equal 18. 2 times 9 and 3 times 6. All of these equal 19, which means I have a lot of possibilities here. All right, but let's go with 9 and 2. So then the next question is, what times what is negative 12? What times what is negative 12? This is not a trick question. Peter? 4 and negative 3. So I'll put 4 here and 3 here. Now, I know that 9z times 2z is 18z squared. I know 4 times negative 3 is negative 12. So I know that the quadratic term and the constant term are going to work. I don't know about that linear term. So let's multiply out and find the linear term. So we have our distribution rainbows. 9z times negative 3z is negative 27z. What is 4 times 2z? 8z. And so when I add these two together, what do I get? This is equal to negative 19, I'll write this here, negative 19z. z. Now, is that matching my linear coefficient here? No, it is not. 19z is not the same as negative 19z. And I have to thank the people who gave me numbers, because they gave us numbers that may not have gotten us the right answer, but it's telling me what the right answer is going to be. How do I make this to be positive? What do I need to do for my binomial pair that would give me a positive 19z? It's an easy change here. Sam? So switch these signs? Okay, so we have 9z. You told me to switch the 4 to negative 4. And we have 2z, and Sam told us that the 3 is going to be positive. And so let's double check. So we have 9z times 3, which is?
27.
That's positive 27z. I have negative 4 times 2z, which would be negative 8z. And when I add those together, I do get 19z. All right, so this is clearly the answer. Now, here's how I would do things when I was an algebra student, back when I was in 8th grade as well. So I would write out the factor pairs like this, and then what are the pairs of 12? 1 and 12, 2 and 6, and 3 and 4. So I just write them out like this. So right away, so what I'm doing here is I know that I'm going to multiply one number from here and one number from here, and then I have to subtract down to this linear term here. So in other words, we multiplied the 9 and the 3 to get 27, and then we had to subtract 8 to get to 19. So I know I have to multiply two numbers together that's going to be larger than my linear coefficient, and I'm going to subtract the other two down. So I'm looking here, and what two numbers multiplied together give me a number that is a little bit bigger than 19. Well, right away I know that 18 and 12, if I multiply these by these other numbers, I'm going to get a number that is way too big. So I can eliminate the 18 and the 12, which means this, both of these, they're not going to work. So then, okay, 6 times 4 is, and if I subtract the 3 times 3, 24 minus 3 times 3, which is 9, 24 minus 9 is not 19. So I know that doesn't work. And I know that I can't, so I can do 6 times 6, which is 36, but 6 times 3 does not subtract down to 19. The only way I can do this is I know that 9 times 3 is 27, which is just a little bit bigger than 19. And then 4 times 2 is 8. So therefore, I have to use this pair and this pair. I don't know if that helps you, but that's how I think about it. What two numbers multiplied together, in this case, are a little bit over, and then I subtract down. I don't know if that helps. Michael, does that help at all?
Yeah, it's kind of what I do in my head. It helps right now.
Yeah. So yeah, I like to write out the factor pairs. That does help me too.